Good afternoon, ladies and gentlemen. First of all, thank you very much for the invitation from Green Council, so that I have the opportunity to come and share with you some of the experience CLP has done in terms of helping Hong Kong to have a kind of a clear blue sky and fighting the climate change challenge, as what Queenie just mentioned. Actually, Queenie has just done a very good job in helping me, save some of my effort in explaining some of the background about the climate change challenge. So actually, when I go through my material, I will kind of skip some of the material that Queenie has mentioned, but then I will supplement a little bit on the non-utility perspective. In particular, for example, other sectors, and also from the public's or customers' perspective, how they can help, contribute to this carbon reduction journey. Now, first of all, I would like to give you a very brief overview about the previous journey that CLP has gone through. And actually, you saw this diagram, which is quite familiar to you, right? Because just now, actually, Queenie also mentioned that. Now, the whole story, as Queenie mentioned, dated back to actually 2010, when the Paris Agreement and also Chinese government set a target to reduce carbon by actually they are using carbon intensity. That means carbon emission per GDP. The carbon intensity reduction by 2020 has to be a reduction of 50 to 60% from 2005. Now that actually is Hong Kong's target. But if you look at mainland China, it was 40 to 45%. So Hong Kong being part of China and also more developed, so actually I would say we do a bit more, than the average. Now that's the first step, and then 2017 the government further set a 2030 target, which the carbon intensity will reduce by 65 to 70%. So those are the targets that we have to fulfill. And because 2/3 of the carbon emission in Hong Kong is from power generation, so definitely, power companies play a very key role in contributing to the reduction. So what CLP have done? First, actually, we have already set out a plan to gradually phasing down coal-fired generation in Hong Kong. Last year, we have our latest development plan approved by the government, in which we propose to gradually phase out our Castle Peak A power station. Now, right now in Hong Kong, for CLP, we have 3 power stations: Castle Peak Power Station, which is coal-fired; Black Point Power Stations, gas-fired; and a very small Penny's Bay Power Station, diesel oil-fired. Now, for Castle Peak, we have 8 units. We call it 4 units in A station, 4 units in B station. So in our plan, by the middle of 2020s, basically the 4 A unit will reach their natural or the end of their useful life. So we have the plan to phase them down and replace them with gas-fired generation. And in order to achieve the carbon reduction and also the fuel mix, so we have to also import natural gas. So apart from new generation gas unit, we also need to build an offshore energy receiving terminal. And that will be coming into operation in 2021. And apart from the supply side and also from our conventional generation, we also try to do non-fossil fuel generation, including renewable energy, landfill gas generation. In one of the landfill sites just adjacent to the Black Point Power Station, we help the government to connect their facility, the waste to energy facility, into our grid, so that they can make use of the waste energy to generate electricity. And we also try to promote renewable energy development locally. I'll talk about it in more detail later on. And as also Queenie just mentioned, we also propose to reinforce the existing interconnection with the mainland China so that we can import more zero carbon energy, from the mainland. Now, all these have already been in place, and we are now executing the development plan. The question is, on top of this is good for, say, 2030, but beyond that, what we should do? Now, I think in order to answer that question, we need to think about a few different questions. First of all, what kind of reduction we want to achieve after 2030? And then, how are we going to achieve that target? Now, in the coming few slides, actually, I want to give you some, I would say, background information, some of the factual information that maybe you find it interesting, so that you understand a bit more about carbon emission. Now, first of all, in terms of carbon emission, I want to kind of tell you some kind of numbers. For example, for coal, per unit of electricity generation, the amount of carbon dioxide emission is about 1 kilogram. And then natural gas is about half. And then for renewable energy, 0. Okay, so these are the kind of factual numbers. Now, currently, the average carbon dioxide emission for CLP, in terms of per unit of electricity, is about 0.5. So how we are going to do that? You can see actually 0.5 is almost close to, say, all natural gas kind of situation. So how we can do it is by means of this diversified fuel mix. So you can see coal, nuclear, and gas. And because of the fact that nuclear carries no carbon, so on average, actually, we can achieve much better than coal generation. And then by next year, because of the fact that we need to increase the proportion of gas to 50%, the per unit kind of carbon emission will drop to 0.4 or below. And actually, going forward, it will be gradually reduced. Now, but later on, there's a limit. So I'll let you know the limit. So that if you take a look at this diagram and the numbers here, so if it's quite obvious, to all of us here, that if we want to have a significant reduction in carbon, we have to have zero carbon energy. Otherwise, actually, we won't be able to achieve such a significant reduction. So the question is, how are we going to, obtain that amount of zero carbon energy? So then, I think the immediate question is whether we can do it within Hong Kong. Now, Queenie just now also provided some numbers. Although actually I quoted some figures from the 2030 plus document, from the government. So Queenie just now said 10% of the renewable energy would be like Wan Chai plus Central plus Western District. That's one example. If we talk about 1%, actually it's like 20 Victoria Park. So basically, land is a very important consideration. So if you look at the map of Hong Kong, a lot of areas actually are not, development would not be allowed. And according to the government, likely it's only like 3 to 4%. Although Queenie also mentioned they are reviewing the numbers, but they do not expect there will be significant increase in terms of this percentage. So if we want to have significant amount of reduction, we want large amount of zero carbon energy, then I think another natural option is to look for regional cooperation. Now, despite the fact that we will look for regional cooperation, but locally, we also want to do as much as possible to help people to develop renewable energy. So that's why under this current scheme of control, we introduced the feed-in tariff scheme. Maybe I just recap a little bit about the scheme. Now, both solar and wind power are so-called qualified renewable energy installations. And then depending on the size of the installation, basically we divide into small, medium, and large scale installations. And the feed-in tariff is $5, $4, and $3 respectively. And when I say the feed-in tariff rate, that's the amount of money we pay to the owner of this renewable energy installation, measuring all the electricity generated from the installation. So you don't need to offset your own consumption. So we'll have 2 meters, one specifically for this installation, another one, the normal meter that kind of measuring your own consumption, and then we give you the bill every 2 months. So we launched the scheme October last year, and up to now, we received, actually that's the statistics by the end of March, okay? We received more than 2,500 applications. We have already approved 83%. Actually, it's, no, I don't know whether you think 80%, 83% is a big number. But actually after our AGM and quarterly result, one of the newspapers said we only achieved 83%, which to me is a bit strange. The reason is because actually in the past few months, every month we receive more than 300 applications. So actually every month we add more than 10%, on top of this. So for all new application, we need time to process, right? So I think 83% actually is quite a good number already. Now, but despite that, then definitely there are some applications. I don't know whether audience here had any experience of submitting applications to us, but some applications we do need to have more time to process. The reason I just want to summarize here. Actually, most, if not all, of those applications we need more time to process, they are all located in rural areas. And some of them actually are in quite remote areas. So because the fact that we need to absorb that electricity, we need to connect the installation to our grid. Okay? So the challenges are sometimes, of course, if the customer do not submit complete information, it's difficult for us to process. But there are a lot of technical and safety issues. For example, in the rural area, actually, there may be only a few customers there. The network there is very weak. So, but then they may have an appetite to build a relatively large, for example, PV installation. The network cannot accommodate such big installation. So we need time to reinforce our network. Sometimes, even they propose to build a PV network, PV installation, where we do not have a network at all. Basically, it's like a no man's land. So again, we need to, work out a scheme, to build a network. And we, sometimes if the network reinforcement is significant, we need government approval. So, some pictures showing, the challenges. Some of the village houses is very congested, and there's no surface road for us to lay cables. So I hope that we can continue to improve this number. This is our job. And then, now, after having much effort in the local RE development, then if we look for regional cooperation, then what should we consider? Actually, I think just now some question also touch upon. Now, first of all, what kind of energy we look for? Renewable energy, nuclear energy. Now, those are the so-called zero carbon energy up to now. Of course, going forward, maybe due to technological development, we may have other kinds of zero carbon energy. Now, but up to now, I think I would say more promising kind of zero carbon energies are renewable energy as well as nuclear. And for renewable energy, most common one are wind, solar. From mainland, there may be hydro. In some of the maybe specific area, there could be geothermal. But other than that, I would say the other are still at a very early stage of commercialization. Now, but if we consider those are the type of renewable energy, how we can kind of bring them to Hong Kong, then we need to consider several issues. First of all, as Queenie mentioned, if we import power from the mainland, do we need to know what source, the energy coming from? Now, from our point of view, I think that's a must, because that's an ethical question. If we do not know where the energy is coming from, how do we know those are zero carbon energy? As a responsible utility, we have to ensure that the electricity we provide, we know the content, we know, our responsibility. So from our point of view, I think dedicated sources is necessary so that we will ensure that we know the carbon content. Secondly is, although we have existing interconnection with the mainland, we are going to reinforce those interconnection. But if we want to bring in some significant amount of zero carbon energy, we need additional interconnection. Now, additional interconnection nowadays actually is not easy. The existing connection was built actually in the 80s. At that time, if many of us here may recall, Shenzhen is not well developed. There are still a lot of land that we can use. We can build our own power, overhead lines. But nowadays, if you look at Shenzhen, basically very much developed already. If we want to build an additional interconnection, it's very challenging. I will not say it's impossible, but definitely a lot more challenging than before. And then we have to have support from different stakeholders. Now, this consists of a few different issues. One, regulatory, because we need government approval. Different types of government department in the mainland China. If people here do business with China, the number of different parties in China that you need to go, for seek approval. Secondly is, actually we need to compete with different parties in mainland for zero carbon energy. And that's also important. That takes time. If we say we want to import zero carbon energy, say for example, in the coming few years, I think it's very difficult, because all of them could have been subscribed by somebody. But if we say we want to import additional zero carbon energy, say in 20 years' time, much more easier, because maybe we can start planning to build new renewable energy in China. And then for all these, as I said, be it the generation source or the interconnection, we need time to build. Now for interconnection, our best estimate actually is at least 10 years. We can't have a cross-border infrastructure project to be completed within 10 years. That's, I would say, basically impossible. Yeah. So we need to plan ahead. Now, after considering all this, but one very important point I want to highlight is that reliability must come first. We can do whatever we want, but at no sacrifice of reliability. Why? Maybe some of us here will agree with me that Hong Kong, very densely populated. Now, in terms of skyscrapers, I don't know whether you have seen this statistic. This is Empora's high-rise ranking. This is 2016, but basically more or less the same now. The index Hong Kong achieved is almost 3 times of Seoul and New York. So you may be surprised that actually New York scored ranked number 3, not number 2. And then maybe some of the Chinese cities, they are catching up. Okay, but nevertheless, Hong Kong ranked number 1 is way ahead, than the others. Hong Kong is so congested with high-rise buildings. We have more than 60,000 elevators, lifts in operation every day. Some statistics saying that 50% or more people either work or live on the 15th floor or above. That means you really rely on electricity to enter or leave such buildings. And then we have 5.8 million passenger trips every day on electricity-powered transport. Then, now because electricity is reliability is so important, how power company like CLP maintain reliability. This is just a simple illustration. We have demand, we have supply. In order to maintain the stability of power system, we have to maintain this supply-demand balance all the time. So when I say all the time, it means every second, or every tenth of second, or even microsecond. So actually, whenever there is imbalance, tip the balance, the frequency of the system will change. And in case the change is significant, the whole system will break down. But then people may ask, how we can ensure supply and demand can balance all the time? First of all, we need to track the demand and then adjust our generation to cope with that. Secondly, we need to cater for any emergency situation of our supply. Say, for example, if one of the generator breaks down, then we have the spare generators that we can control, and then we can dispatch them. That means we can turn it on or turn it off in order to fulfill the changes in demand. Now, this is the fundamental concept of maintaining a stability of a power system. Then, just now we say if we want zero carbon energy from mainland, it consists of renewable energy and nuclear energy. Now we will try to use as much renewable energy as possible, because I think it's easily understandable that some people may have some concern about nuclear energy. Now, but I would also like to give you some idea about what renewable energy means. Now, this is solar radiation measured at King's Park. King's Park is just not far away from here, right? So you can see now, but I think some of it is quite obvious. There will be sunshine during daytime, right? So maybe it's from almost like 8 o'clock, and then gradually build up and then die down at around 5, 6 o'clock. And then we will ask, now we have that kind of PV panel, then we can generate electricity. But then if you look at our consumption profile, now these are what we call the system peak time in the last 15 years. This is CLP information, okay? That means throughout the day, at what time our demand is maximum, okay? Now, throughout the last 15 years, you can see all of the time basically is in the afternoon. This is first. Second is a large proportion of the time actually is in the evening, where there's no sunshine. So how can we use renewable energy to satisfy our need? Because as I said, we have to balance generation and demand all the time, right? And actually, this is the biggest challenge a lot of countries now facing. Now, for example, in Europe, as Queenie also mentioned, Europe is a well-interconnected system. So some of the countries, if they have a lot of renewable energy, when they have no, then they can draw power from the adjacent nation through the interconnectors. But why the other nations can provide power? Because they are still burning fossil fuel power station. So that's why they have the capability of supplying power. Now going forward, if more and more renewable energy is to be developed, then who are going to provide that back up to us? So that's why a lot of research has now been undergoing in terms of energy storage. So you can store the energy, and then during the time when we do not have renewable, then we can use them. Now, but they are still I would say under research. Some of those are being deployed, but the cost is really high, still really high. Now this is another example of wind farm. If we look at daily generation, it could vary between almost none of the generation from the wind farm versus almost full output. This is, this is statistics of one of the CLP wind farm in Shandong. Now, so having gone through some of the characteristics of renewable energy and the importance of balancing supply and demand, so I think one way to maintain reliability and then at the same time to maximize zero carbon energy development, firstly is to maintain a certain amount of what we call dispatchable generation. Now, if we could have nuclear energy, then basically we can serve two purposes, both zero carbon and also dispatchable. If we want to have more renewable energy, we need to have some, for example, gas-fired units, which maybe normally we will try to minimize the utilization. But then during times where renewable energy is less, then basically we fire up our backup generation and then make up the shortfall so that we maintain the balance. Now, I think in medium term, for example, in the 2030s, we can still adopt this approach. But if even going forward, maybe towards 2050, because of the fact that we still maintain some fossil fuel here. Now, it really depends on, again, the target of reduction. If we go for a very significant reduction, that means the amount of fossil fuel has to be really small, then actually this may not work. We may need some other things to fulfill that. One option, obviously, is if we have more nuclear, then we can solve the issue. Now, but whether that's something we want, I think is we need to wait for the public engagement, as the government mentioned. Now, I mentioned we are going to phase down Castle Peak A, from CLP point of view in the 2020s, and then actually in 2030s, the remaining 4 coal-fired units will also reach their end of life. So that's our decision point to think about whether we replace it with gas generation or whether we replace it with renewable or nuclear. And then the question is, as I said, although we are talking about 2030s, if we want to build new interconnection, we need 10 more years. We need 10 years at least. So that means the decision on whether we should replace it with whatever types of generation actually has to be made quite soon. It will not be in 10 years' time. It will be in the coming few years. Now, actually, I think I've spent most of the time already. Let me try to speed up. Apart from the supply side, I would also like to touch upon other sectors, as well as from customer. Now, this diagram tells you the UK experience. Now, I don't think you are able to read the words here. I just want to highlight 2 lines. One is the blue line. That means the falling line. Now, this is the power sector carbon emission. So it's decreasing. So one very obvious observation is that once the power sector is improving in terms of carbon emission, then the other sector actually will become the more imminent challenge. And similar to Hong Kong, the next one is transport. And I think this is exactly why I think a lot of us here will be aware that a number of countries, in particular in Europe, they have already made the pledge to phase out diesel or kind of petroleum vehicle by a certain time. Some of them like 2030, 2035, and some of them like 2040. Because they see, even if they basically turn the whole electricity sector carbon free. Now, in particular, in other countries, they have other sectors. Now, in Hong Kong, as I mentioned, 2/3 of our carbon emission is from power generation. Even if we turn this all into zero, the maximum reduction that we can achieve is less than 70%. But in order to achieve the Paris Agreement 2 degree or even 1.5 degree, we may need to have even more stringent reduction. Actually, recently, if you have read some of the news, UK has so-called make a pledge that they want to go carbon neutral by 2050, followed by Netherlands, and I think maybe this week, New Zealand also are making such a promise. So I would see, increasing number of countries, they are making really aggressive carbon reduction target. So it's really our job to think through it, think carefully, and what kind of carbon reduction we want, and then how we can achieve them. Now, about all these are about supply side. So what about customer? So I think one, I would say, enabler to help our customer to save energy is by means of digital technology. Now, actually, there are some research, comparing different solutions of reducing carbon. Energy efficiency is the cheapest way of reducing carbon. So if we can use less, then actually it would be more cost effective. And how we can use less? One way is if we can have digital technology to give us more convenience, if we can have digital technology that can give you more information, then it would help. Now, from CLP point of view, we have been also doing a lot in helping our customers, both in terms of, for example, setting up funds, providing advice on, converting equipment to more efficient ones, carry out energy audits, providing, advisory service to our customer, and we also run, programs or schemes to ask our customer to reduce demand. Now, but one very important enabler, I would say, is smart meter. And last year, actually, the government has approved CLP to gradually roll out our smart meter to all our residential and SME customers in the coming few years. So hopefully, with smart meter, we can help our customer. Now, the way how we can do it actually is to provide information. For example, if we have smart meter, we can provide more granular information. We can let you know your hourly consumption at your household up to the last hour of the past 24 hours, or daily assumption of the past 7 days, so that you can observe your behavior and identify opportunity for saving. And we also run benchmarking exercise. Just taking some of the basic information from you, we can then compare your consumption with similar kind of peers, so that you can have a opportunity to save energy. I just like to borrow a few minutes. This is a short video. We run what we call a Power Connect program, which is a energy saving program for all our residential customers. The more they save, the more points they can earn. So it's like a loyalty program, and then you can use your points to redeem gifts from us. 冇聲。So those are the details, and maybe I don't want to go into detail because of time. Another thing is about EV. As I mentioned, for other sectors, transport is definitely one of them. And EV actually has a lot of advantage, including much lower carbon emission, much lower air quality, and also much more energy efficient. And then last but not least, in order to involve everyone, we also have been doing a lot of education. Actually, this is, I would say, the whole spectrum of our curriculums. One, spending from kindergarten, we have a education kit. And then for primary school, we have Green Studio, we have the Green Elite Campus, accrediting the energy efficiency performance of campus. We have, for secondary school, engineer in school, and also liberal studies portal for more senior secondary students. And then for tertiary institutions, we have the CLP Power Academy, we have the Low Carbon Energy Education Center in City University, and we also regularly conduct career talks, scholarship, and also internship. So we want to cover basically everyone, in particular young people, to join this journey. So to conclude, I would say, in the past decades, in particular, maybe past 30 years, CLP has been, providing very reliable electricity. At the same time, although the demand of electricity went up by 80% in the past 30 years, the amount of emission actually went down also by 80%. It's by means of changing the fuel mix, providing more advanced technology in our power system, but more importantly, I would say, it's because of CLP's power expertise. So I would say in CLP's professional hands, everybody will stay, have a peace in mind. And we will work with Hong Kong people together along this climate change journey to turn Hong Kong into a low carbon city. Thank you very much. To end, if I can still borrow a few minutes, this is the video that we try to promote our Clear Blue Sky.
Under the blue sky, the sun shines bright. Lives are full of colors and wonder. We promote the use of renewable energy, including solar and waste-to-energy, to achieve our mission-free ambition. Blue sky brings us closer and gives us more time to spend with each other. We do our best to enhance energy efficiency and encourage energy saving through changes in the way we use electricity. Blue sky lightens up our days and frees our minds. For this, we all have a role to play. You and I. Together, we can bring a clear